All right. Hey, everybody. This is our second video of the week. And we'll be adding some new vocab to our language of linear equations. All right. So now we'll be talking about parallel lines and perpendicular lines. Yes. So, let's get started. Let's jump into it. Two lines are parallel if they have the same slope. All right? The same slope. All right? Now, because they have the same slope, these lines would never intersect unless they have the same y-axis. In that case, if a line has the same slope and the same y-axis, it's going to be the same line. So I'm just going to tell you that two lines are parallel if they have the same slope and a different y-intercept. All right? So I can say, characteristics of parallel lines. Of course, we got the same slope. They never intersect, and different. And they have different y-intercepts. Yeah? Yeah. I think and these two are mainly as a result of these two points here, this guy and this point, are as a result of them having the same slope. All right? So how about we look at an example, all right? And I'm going to go to Desmos for this one. But so example, I'm going to give you two lines. I'm going to use point intercept form to write these. I'm going to have, let's say, 5x plus 3. And let's see, we're going to have y is equal to 5x plus 2. All right? So that's my example. So let's go to my Desmos app right now. Oh, oops. So I said 5x plus 3. Let me graph my 5x plus 3. So that's in green. And if I graph 5x plus 2, I think those are my equations, right? Yes, 5x plus 3 and yeah. You see, they are both going in the same direction, but they never intersect. Desmos allows me to just go. Right now, they only look as though they're intersecting because I've zoomed out so much. But if I zoom in again, I'll show you the gap. And look at these numbers on the y-axis. We have a 396 right here. 396, we have 77 and whatnot. They never intersect. Those are parallel lines, all right, because they're the same slope. And remember, slope is just how the line changes, just in case you don't remember up to now. All right. Now let's move on to perpendicular lines, all right? Two lines, let me use a different color for this one. Two lines are perpendicular if they intersect at 90 degrees. All right? All right? So that intersection needs to form a 90-degree angle. All right? So let's see. So like if parallel lines look like this, all right? If my parallel lines look something like this, all right? Roughly. Then my perpendicular lines and my perpendicular lines look something like this. This is disgusting. It's not perpendicular. Okay, straight line. Yes. Come on. Why is GoodNotes failing me? All right. Anyway, this looks approximately perpendicular. All right. So this is my line 1. And this is my line 2. When they intersect, they form a 90-degree angle. All right, 90-degree angle. So see, you got 90 there. You got 90 there as well. You know, it's just all 90 degrees. You know. So this is what we mean by perpendicular lines. All right. So a characteristic, they intersect at 90 degrees. Yeah? Also. All right? These intersect. Parallel lines never intersect. All right? So, yeah. And mathematically, what do you think this means about the slope? All right? So, mathematically, the slopes are negative reciprocals of each other. All right? They're negative reciprocals of each other. All right? So if my line 1 has a slope, we've used the slope of 5, for example. Then for my line 1 and line 2 to be perpendicular to each other, I need to first make the number negative, all right? And then take its reciprocal. And the reciprocal of any number is just that same number as a denominator where the numerator is 1. All right, so 1/5. All right? And you know, we've used the constant m in this class to represent slope. So 2 lines are perpendicular. Let me write this in point slope form. All right. Let's see. 2 lines are perpendicular. So perpendicular lines will follow this format. All right. If we got y1, which is in line 1, mx plus b. Let's say I have this line. Then y2 will be perpendicular to y1 if my line 2 has a negative slope and is taking the inverse or the reciprocal of of my slope of y1. Yeah. So let's see what this looks like on Desmos. Yeah. Let me test the function. Let's see. If I have, let's keep it the same way. If I have y equals 5x plus 3, I expect it's perpendicular for a line that's perpendicular to it to have y equals minus 1/5 x plus 3. Yeah, let's see that in Desmos. So all I need to do is say 1 over 5, and then let's see what then. It needs to have the same. Yes. Actually, the y-intercept is irrelevant actually, but I just want to show you that it's because of the. Oh my God! Okay, I should just type from the beginning. 1 minus 1 over 5. That's our slope. Let's see, plus 2. I've got my x. Yes. So now where's my function? Yes. You see? How do I scale this? I want to scale this equally. Okay. And yeah, these two lines here are perpendicular. The y-intercept only just adjusts where my function is going to be, but these are perpendicular lines. Like if I tell you that both my intercepts just going to be, let's say if I have x plus 3, x, I got an x over there, just the x, and minus 1 over x, I expect that line to just be the other. Oh, I mean, that's the product symbol. Minus 1 over x. 1 over x is approaching. This is a bad example. This is a very, very bad example. Apologies. So my slope there is, I need minus 1. It's going to be 1. So I just say minus x. Yes, minus x. Yes, because minus 1 over 1 is x. All right? So minus 1 over 1 is 1. All right? Let me rephrase. So these two lines here, these two lines cut each other and form a 90-degree angle. All right? Let me use a less complicated example, because that example was pretty complicated. If I have a line, y equals 2x, all right? Then, this perpendicular line would be y equals minus 1 over 2x, all right? And all that's going on here is that they are cutting each other and forming a 90-degree angle. That's really all that's going on here. All right? And don't worry, we'll clarify this in class. I apologize for my earlier mistake there. I just graphed a function, and the function of 1 over x is, and the slope, I graphed a function instead of actually graphing the actual slope. If you are confused in this section, don't worry, we'll clear it up all in class. And yeah, I hope you have a good day wherever you watch, whatever time you're watching this from. All right, see you guys. Bye. Oh, and just one last thing. The y-intercepts here are kind of irrelevant. Because really they just tell us where the lines are cutting. But if two lines are going to infinity all the way, then it doesn't really matter necessarily where they're cutting y from. So, because eventually they will link because of their slopes. So yeah, all right. We'll talk about this a lot more in class. I hope this gives you at least a good frame of what we're doing today, or on Wednesday. All right, see you guys. Bye.